Hey, hi YouTube, how are you? I hope you all guys are doing great. In this video, we are going to see about list and tuple. This is going to be a masterclass where we are going to explore each and everything about list and tuple. So, what we are going to cover in this video, as you can see in this tag, that first we will see the basics of list, where we will understand about indexing, slicing, mutability. Then we will see some common list methods like append, insert, extend, remove, and many more. Then we will see how we can loop through list. Then we will see a very important topic, which is list comprehension. Then we will see shallow and deep copy. Then we will be solving like more than five real world coding questions that can come in your online assessment, or it can be asked in a Python developer interview. Then I will give some interview level tips regarding list and tuple. And then we will start with tuple introduction, tuple packing and unpacking, common built-in methods around tuples, slashing, and how tuple is immutable, and also we will see the uses of tuples. This can be a perfect video for Python beginners, student of job seekers, or anyone looking up to level up their list and tuple handling skills. So before this video, I have also created some a masterclass on a string and functions, so maybe you can also watch it if you want. And this is just a simple one pager, and I will upload all the code here. Like you can see, for a string and function I have already uploaded it. I will also upload it for list and tuple. And this is my channel, so if you find this video helpful, you can also subscribe to this channel. Okay, so let's start with the introduction, and definitely I'm going to use VS Code. You can use any kind of code editor. It can be PyCharm or whatever suits you better. So first of all, let's see what actually list is. But before moving directly into the coding, I always create a virtual environment. So it's a good practice to always create a virtual environment. So this is the command which you can use in Windows as well as Mac. And we have created a virtual environment. In the left panel, you can see we have created a virtual environment. Now let's activate it. So source.venv bin slash activate. So it will activate our virtual environment. Basically, virtual environment separates the environment. Okay, each project should be run on a virtual environment always. And if you are on Windows, just don't use source. Just type your virtual environment slash bin slash activate. Okay, it will activate your virtual environment. And if you are facing any difficulty, if it is completely optional, you can also um, it's okay if you even don't use virtual environment, but it's a good practice. Okay, so first let's see what is list. So list is basically uh, a data structure, and if you don't know about data structure, in simple words I can say a data structure is a way to store and organize data so that we can access and work with them efficiently. Think of it like a container, just like you use a folder to store your documents in a computer. Python gives us special containers to store different types of data like list, tuple, set, dictionaries. So in this video we are going to see list and tuples. So now coming to list. Basically list is a built-in Python data structure used to store multiple items in a single variable. Okay, so let me show with some code. So it will be our list intro dot py. So first of all, we will see how actually list looks like. So if I name a variable my list, and I can add anything in the list, 10, 20, I can also add a name like hello, and I can also add a boolean value like true. So this is my list. If I want to print my list, I can simply print my list like this. Okay, so let me just run this. So we have created a list, and the list looks like this: 10, 20, hello, true. Okay, if you want to see the type of the list, you can also look at it. Okay, type of the list. So you will get a class list object. Okay, So list is a built-in Python data structure used to store multiple items in a single variable. It can contain anything. No need to have all the variable as homogeneous in nature. It can be heterogeneous in nature. What are the properties? So first property is it's ordered. If you print or iterate over a list, you will get the same items in the same order you inserted them. So if you see at 0th index we have 10, at one index we have 20, at second index we have hello, at third index we have true. Every time we will iterate over this list, we will get it in the same order. In the same order we have inserted them. Okay. So this is what ordered means. If you will, whenever you will study about set, so set doesn't guarantee the order, so it is unordered. Okay, then it is mutable. We will see what actually mutable is. Mutable means we can also change the list. String was immutable. In string video, masterclass video, I have taught you that string is immutable because once you make a string, you can't change it. It can also contain mixed data types. See, integer, string, then we have also added a boolean. It can allow mixed data types. It also allows duplicates. If I write like this 10, still it will work. So you can see 10, 20, hello, true, 10. So the properties of list are they are ordered, they are mutable, they contain mixed data types, and it allows duplicate. Okay. Now let's see how what are the different ways we can create a list. Okay. Create a list. So first way is you can create an empty list like this, or you can create list with some elements, or you can have some mixed types that we have already seen. It can be one, two, hello, and you can have true. Okay, then you can also have float things 3.14, or you can also have a nested list. Okay, so you can have one, two, and then you can also have a list inside list. Okay, so it's fine. So these are all the way you can create a list. Just to show you, I can do like this. So print a, uh, b, c, b, and c, and then just go with the d. So now if I will print it, first I got an empty list, then I got a list with 1, 2, 3, then I got a mixed type of list, then I got a list inside list 1, 2, and then a list and 5. So this is how we can create a list. Now let's see how we can access the elements in a list. Okay, so let me just erase it, just comment it. We can say accessing elements in a list. Okay, so how we can access elements in the list? So let's create a variable uh, fruits fruits, and it can contain different fruits, banana, we can say any more food, cherry. Okay, now let's suppose we want to access any elements in the list. There are three elements in the list. And how we can also check whether how many elements are there in list. So we can use a function length. It's very basic. It's simply like English, like we can use len. So any len denotes length. If I pass this list here, which is fruits, so it will tell me the length of this list. So if I just run it, I got three. So there are three elements in the list. Okay, just it was just out of the box. I wanted to. I will keep explaining this kind of things, yeah, in between the videos. So please focus. Okay. So how we can access it? Always remember, in Python or in any programming language, most of the programming language, indexing starts with 0, not from 1. So this apple is at 0th index. This banana is at 1 index. This cherry is at second index, 0, 1, 2, 3, 4, and so on. So if we want to print the first element, so first element always comes at 0th index. So fruits 0. So it will print the first element which is at 0th index, which is apple. If I want to print the second element, so I will do 1. So now it will print apple because apple is at 0th index. At 1 index we have second element which is banana. If you want to print the last element in a list, so you can also do -1. Okay, reverse indexing also, it is also allowed in Python. In C++ or Java, I think it's not allowed. So zero minus one, if I just remove this, minus one will print the last element. So it is giving me as a cherry. Think of, you have a very long list and you want to print the last element. So you can just do minus one. If you go from back, this is minus one, this is minus two, and this is minus three. Okay. If you go from left to right, it is zero, one, and two. Okay. So this is how you can access the elements. Okay, and this is also called as indexing. Now let's come to I will just copy this because we are going to use this example only, and now we are going to see about slicing. Okay, slicing and all these concepts are very similar to any you can say any data structure, whether it is string, it is list, or tuple. If you know slicing in any of the data structure, all are literally same. So let's suppose I want to slice and I want to just have these two elements. So what I can do is print sorry print fruits. I just want to have two elements, these two elements. And first element index is 0 and second element index is 1. I want elements from 0 to 0 and 1. Okay. So what I will write here, I will write 0, comma, not 1. I will write 2. Why? Because the upper index, this 0 is the lower index and this 2 is the upper index. Upper index is not included. Okay, it is excluded. So if I just write 0 and 1, so it will start moving from lower index, so it will go to 0. It will print it. Then it will go to upper index, and upper index is not included, so 1 will be not included. So let me show you. If I just print it, I will just get apple because this 1 is not included. Okay. If I do it as 2, so it will start with 0, it will print it, it will move to 1, it will print it, it will look to the then it will move to 2, but 2 is the upper index, so it will exclude it. So 2, it will just print the value which is at 0th and 1 index, not the upper index which is 2. So it will just print apple and banana, as simple as that. Okay. Wherever there is 0, we can remove it. This is also fine. This will also work like this. Okay. Now let me add some more pineapple, uh, watermelon. Okay, cool. Now let's suppose we want to print, or we want to print elements from we want to print banana, cherry, and pineapple. So banana is at 1 index, so apple is at 0th index. Let me just write it for your understanding. This is 0th index, this is 1 index, this is 2 index, this is 3 index, and this is 4 index. Okay, because indexing starts from 0 to and so on. So now if we have to print banana, cherry, and a pineapple, we have to create a list. From this list, which will be containing banana, cherry, and pineapple. So it should contain the elements from 1, 2, and 3. It should contain 3 elements, 1, 2, 3. So how the code should look like? So print, why I always write print wrong? Okay, print fruits. Now what should be the starting index? Because we have to put banana, cherry, and pineapple, so starting index should be 1. What should be the end index? uh, do you think it should be 3? No, because if I just write 3, it will not include pineapple. So just let's see here, it will not include pineapple because what I told you, that upper index is not included, it is excluded. So that's why we have to always add 1, so it will be 4. And now from 1 to 4, so banana, cherry, and pineapple are in our list. So this is how slicing works. Okay. And that's it. Okay. One more thing, there is lower index, upper index, and also there is a step. Okay. So if I do like this, print fruits, and if I start from starting, because if I can also write like this. Okay. Do you think this is correct or not? Okay, sorry, I just made a mistake. I can also write like this. So as I told you, if we have not added something, like here you can see there is no lower index, it means it will start from the very beginning. And if we are not, even if we are not adding something like this, okay, like the end index is also not there, so it is telling us that it will move to very end. Okay, so if I just do it, I will get apple, banana, cherry, pineapple, and watermelon. It means that include everything from start of the list to the end of the list. If we mention it like 1 and 4, it will use it, but if we don't mention the lower and upper index, then it will take each and everything from start to the, from beginning to the end of the list. There is also one more thing, if if I can say start from 1 and move to 5, and if I write like this a step 2, so let's see what will happen. So now it will print banana and pineapple. Now try to understand what this last parameter is. So first one was starting index. So start from 1, and the second one was go to end index, because we want to include everything after 1. So we added 5. So 1, 5, and then we added 2. What this 2 means? 2 means steps. So start from 1 and move 2 step. If we go to 1 step, we will add land on cherry. If we take 2 step, we will land on pineapple. So that's why we got banana and then pineapple. Okay, by default it's 1, so that's why we the steps are 1. But currently I have mentioned that every time you have to move from lower index to upper index, but every time you have to jump by 2. So that's why we got banana, then pineapple, and then nothing, because there was nothing. Let's suppose I make like this. So I'm telling that start from very beginning, move to very end, and always have a jump of 2 steps. So what will be the answer? It will start from here, it will jump 2 step, it will land on cherry, it will jump 2 step, it will land on watermelon. So we should be seeing apple, cherry, and watermelon. So see, apple, cherry, and watermelon. And if I do like this, see, if I do like this, it means that start from, see, start from end to beginning and move 1 step back. Okay, this is a very smart way to reverse a list. Now we have got watermelon, pineapple, cherry, banana, apple. Okay, so this is how slicing works. Okay, it is not always like it will start from beginning to end. If you just write like if you leave it empty, it is like a range where it can move from backward as well as forward. But this minus one is telling that you have to move backward. Okay, if we just write as 1, it will move forward. Okay, so now we got apple, banana, cherry, pineapple, and watermelon. Okay, so this was a very smart way to reverse a list. Okay, cool. So that's all about slicing. Now let's see what actually a mutability is. Is our list mutable? So mutability. Okay. Yes, list is mutable. What I mean by list is mutable. So if I just take this list, okay, let me take this list, and if I print this list, so what I will get? I will get just fruits, nothing else. Okay, I got a list. Let me just clear it. Okay, I got a list. Now, can I change the list? We have seen in string, we cannot change the string, we cannot change a character. Okay, but let's suppose at zeroth index, which is the first element, because indexing starts at zeroth level, I want to replace the apple with mango. Okay, now is it possible if I print the fruits? Let's see, if I print the fruits, what will happen? So initially our list was apple, banana, cherry, pineapple, watermelon, because I have also printed before the mutation. Then I added at zeroth index, I added a fruit which was mango. It was replacing the zeroth index which was apple. So it also replaced it mango, banana, cherry, pineapple, and watermelon. So this means that we can also change the elements of a list. It means the list is mutable. Okay, is it clear? Fine. What do you think? In this section, we have seen lots of things until mutability. So we have started with data structures, then we have seen list, what are the properties of list, how we can create a list, how we can access the elements, how we can do indexing, how we can slice a list, and then we have also seen mutability. In the next section, we are going to see the list methods. In this section, we are going to see the list methods. So we are going to use this list only, and let me create a py file, a module which called list method. So we are going to see all the list methods in this section, and I'm going to just clear it out. Okay, so this is our list that we are going to use, and first method that we are going to see is append. Append is basically used to add some elements to the list or even a list to the list. Okay, so I can add something like fruits dot append, and I can append any fruit. Let's suppose I added orange, and if I just print it, I will get a new list which will be containing uh, also orange. So I got apple, banana, cherry, pineapple, watermelon, as well as orange. So we have appended some values to this list. Okay. The second one is going to be insert. Okay. I can also insert some item at a specific index. Okay. Let's suppose I want to insert in fruits. I want to insert something. Okay. And if you see these, you can say the definition. So it takes an index and an object. So at what index we want to store something. So let's suppose we want to store at this index, which is one index. So we can pass an index here, and then we can add an element. Let's suppose we added melon. Okay. So if I just print it, so I got something as like this. So initially our list was apple, banana, cherry, pineapple, watermelon, but at its one index now we want melon. So we got apple, melon, then everything shifted to right. It didn't replaced it, we just inserted an element. The rest list will just shift by one to the right. Okay, so this is how insert works. Then we also have extend. Extend, which adds element of another list or iterable to the end. Okay, let me explain you what I want to say is the next is extend. Okay, so extend, let me just show to you. Dot extend, it takes a iterable. Okay, if you see this, extend takes a iterable. So iterable means it can be a list, it can be a set, it can be anything. Let's suppose we have a list. Okay, we have a list as more fruits. Okay, and that list contains some fruit like kiwi. I'm out of fruits now, I guess. uh, Blackberry, I think it's also a fruit. Now I want to extend my original list with these fruits. So I can just add more fruits. And now if I print these fruits, what I will get? I will get a extended list. So initially my list was apple, banana, cherry, pineapple, watermelon, but now I have also added added the elements of the list, not the whole list. I have added elements of the new list, which was more fruits in the fruits. So I got apple, banana, cherry, pineapple, watermelon, kiwi, and blackberry. Okay. Then we also have a method as remove. What actually this remove does, remove takes a value, it removes the first occurrence of the value. Okay, so if I do fruits dot remove, sorry, not reverse, remove. So you can also always see what this because how this function looks like, what it takes, what it does. You can also explore it by your own. Remove first occurrence of the value. If we have, because list has can have duplicate values, so it can have multiple um, occurrence of the same. Like apple can repeat multiple times, but it this remove will only remove the first occurrence of it. Okay, so now if I will remove this apple. Okay, so now initially we had a fruits list of fruits as apple, banana, cherry, pineapple, watermelon, but now you can see what we got. Okay, sorry, I forgot to print it. Okay, print fruits. Okay, so now see, apple has been removed. We are just left with banana, cherry, pineapple, and watermelon. Okay, cool. Now um, what we can see next, pop. Okay, we can see pop. Pop takes an index and it removes and returns items at a given index. And if you don't mention any index, by default it removes the last item. Okay, let's suppose last item, or I can say popped item. Okay, popped fruit, and let's suppose I do like fruits dot pop. So it will remove, and let me print the fruits. Let me print fruits. So inside pop, see, it removes and return item at index. By default, it removes the last element. So we had our list as apple, banana, cherry, pineapple, watermelon, and we have done the pop. So it will just remove the last element, which is watermelon. Okay. If we are trying to remove any element from a specific index, let's suppose we want to remove pineapple. So pineapple is at -2 or 0, 1, 2, 3. 3 will also work, or from backside -2 will also work. Let me go with -2 this time. If I just mention -2, so it should remove pineapple. So now if you see, pineapple has been removed. Apple, banana, cherry, and watermelon are left. Pineapple has been removed. Okay. Now let's suppose you want to clear the whole list. Okay. So what you can do? Let's suppose you want to clear the whole list. How it will look like? So fruits dot clear. Okay, and then we can print the fruits. Okay, so it will clear the whole list. Now we are left with no fruits. Very sad. Okay, don't think like if you are having a confusion like I added here, then where when I added an orange, and why when I executed this insert, where the orange went. So it doesn't like that. Okay, every time I'm running the program, so program is starting from one line. Okay, I have added a comment, so that's why this orange is not getting added. Okay, so this is clear, which actually removes all the elements, all the items from a list. Now let's move to another method, which is index. So index, by the name it is clear, it gives us the index of any value. Okay, so if you want to have an index of any value, I can just print it directly. Okay, so fruits dot index. So you can see the syntax of index. It takes a value and it gives an integer, returns the first index of the value. It raises a value error if the value is not present. So if I want to see the index of, let's say, apple. So what is the index of apple? The index of apple is 0. Okay, which is at 0th index. Okay, and if I add something as kiwi, so it will give the index of kiwi, but kiwi is not in our list. So that's why I told you, see, raises a value error if the value is not present. So if the value is not present, it will throw a error. Okay, so this is how we print the index of any element. Then we also have count. Okay. Mm, Maybe we can store it like x or uh, count 1 is equals to fruits dot count. I want to find the count of a fruit which is kiwi. Okay, and I want to print it. Either you can print it here like this, or you can also print directly, well, like here in the 31 line that I have done. Let me also comment this part. This will be easy for you to refer. So count, basically here you can say count takes a value and returns the number of occurrence of the value. So how many times kiwi is appearing? 0 time, because we cannot see any kiwi here. If I just add apple here, so it should return once, because apple is repeating just once, it is having one, so occurrence of apple is just 1. So we have seen index also. Now let's do sort. Okay, so sort is basically sorts the list in place, permanently changes the list. Okay, so if I do fruits dot uh, we have to do sort, and okay, that's all. And let me just print the fruits. Okay, cool. So let's see what we will get. So it is now sorted. Initially, banana, cherry, pineapple. Oh, actually, it was already sorted. So if I just make it like, let me just change this list a bit. Okay, so this is not sorted because after A, B should come. So after apple, banana should come, then cherry should come, then pineapple, then watermelon. So that's why I just made that list unsorted, and I'm just commenting it. So now if I will run it, I will get apple, banana, cherry, pineapple, and watermelon. We got a sorted list. So that's why sort is important. Sorts the list in place. Permanently it changes the list. Okay. Now see, it's not changed in the fly or something. It changed the list permanently. That's why even in this line, in 42 line, I wasn't able to print the list. So this is a really important interview question, that the sort that we use sorts the list in place and it permanently changes the list. Okay. Now there is a very helpful method which is reverse, which we heavily use. So we have a list as apple, cherry, banana, pineapple, and watermelon. We want to reversal it. So whatever is now watermelon should be at the zeroth index, pineapple should be at the one index, and so on. We just have to reverse the list. Okay, fruits dot reverse, and we can directly print it. Okay, we can directly even print it. Okay, just print it. Okay, so see, none. Okay, we are getting none because we cannot directly print it here because um, fruits dot reverse will give nothing. Okay, it is returning none. See, okay, so we have to print the fruits, print fruits. Okay, so now this list should be reversed. Initially watermelon was at end, now watermelon became at the zeroth index. Pineapple was at second last, now it became second, like at one index, and so on. So we have reversed the list. It is really helpful. Then we can also have a copy. Okay, copy. So copy is basically returns a shallow copy of the list. I will explain you what is shallow copy and deep copy. For this moment, just remember that this copy method is basically does shallow copy. Okay, copy fruits list. Okay, so if I do fruits dot copy, so it will copy the whole fruits into copy fruits. We have created another list which is copy fruits. So if I print copy fruits, this will be having the same value as the fruits that we have. In fruits, we have apple, cherry, banana, pineapple, and watermelon. Now we have copied the fruits into copy fruits, and I'm printing copy fruits, not the fruits. So I'm getting the same list: apple, cherry, banana, pineapple, and watermelon. So it has copied the whole list and created another list. Okay, simple. There are some more methods also which I want to show you. Let's suppose we have numbers, and sorry, we have numbers. Let's suppose 1 2 3 4 5. We can do something like as numbers dot sum. So this will return the sum of the numbers. Then we can do what else we can do, numbers dot max. So it will give us the max value. Let me just check whether this syntax is correct or not. So okay, list object has no attribute sum, so no worries. I think we have to pass it like this. Okay, so numbers. Okay, even I don't remember each and everything. Okay, you can take the help of ID and all because it's fine. Okay, so numbers we have done the sum of all the numbers in the list. Similarly, we can find max and min in these numbers. Okay, we can find max, we can also find min. Okay, so we can also find min. We can also I think we have already seen a similar method. This is length. Okay, so we can do like this. So now we have sum of all the numbers: 1 plus 2 plus 3 plus 4 plus 5 is 15. What is the maximum number? 5. What is the minimum number? We got 1. And what is the length of this whole list? Which is 5, which we have 5 elements. Okay, length is different and indexing is different. Okay, so that's it. In this section, we have seen lots of list methods, and all these list methods sometimes are really important whenever you solve some different level of questions where you need to reverse it, when you need to sort it, when you need to remove some elements, when you need to pop some element. So it's really important. Okay, so and I think I haven't taught you this thing that okay, remove, whenever we are removing something we have to mention the element, but when we do pop we can pass the index. Okay, if you see the difference here, I don't know whether you have this question or not. So remove uh, takes a string, but pop takes a index. Okay, and by default it is set to -1. Okay, so this is the difference between remove and pop. Okay, and the next section we are going to see how we can loop through the list. So meet you in the next section. This section we are going to see how we can loop through a list. Okay, so basically if you see how list looks like. Okay, so I try to have a whiteboard here so that I can explain you much in a much better way. So whenever we have a list, okay, so let's suppose we have a list like this. Let me just zoom in. Okay, we have a list like this. We have apple, we have mango. Sorry for my bad handwriting. We have cherry. Okay, so how the indexing looks like? This is zeroth index, this is one index, and this is two index. Whenever we have to loop through the list, we have to start moving from this to this, and every time we will do some operation with the first element, then second element, and then the third element. This is how basically we are going to iterate through the list. Okay, so let's create a third one, third, I can say third list, what we can say loop. Okay, I'm going to cover a lot of things in this video, in this section, but first let's start with how we can loop through a list. Okay, so let's suppose we have a list. Let's take the same list which was fruits. So let's take this list only. So let's go with this list. And if we have to iterate over the whole list, so it's simple for then the variable name for fruit in fruits. Okay, so we have to iterate over this list, and each time that I shown you here, that first we will whenever we will iterate over the list, first will be this apple, then we will move to mango, then we will move to cherry. This whole thing we have named as fruits, but at once this will be called as fruit, then next time this will be called as fruit, third time this will be called as fruit, one by one. Okay, cool. So if I just print the fruit, okay, not fruits, if I just print the fruits, sorry, fruit, so we will get one by one each element. Okay, so first we got apple, then we got cherry, then we got banana, then we got pineapple, and then we got watermelon. Simple. Okay. Okay, if you want to print, so what you have understood till now, we have a list which is fruits, and every time whenever we iterate, we just write like this fruit can be anything, this is just a variable, okay, x in fruits, so every time x. So if you just print this, we got apple, cherry, banana, pineapple, watermelon. So we are iterating over the list, and for the first time this x will be apple, second time this x will be cherry, third time this x will be banana, fourth time this x will be pineapple, fifth time this x will be watermelon, and finally the list will be complete. So this is how we iterate over the list. I think you already know about for loops and all, so this should not be a big problem for you, okay, because this all things comes under for loops and all. Okay, just a second. Okay, cool. Okay, now what if I also want index while printing the list? Okay, so what we can do is, for we want index as well as we want the fruit. Okay, in we can use enumerate. Enumerate does this job. Okay, it gives basically the element as well as the index of it. So if I just print something like this, index and fruit, okay, so it will also print the index as well as the fruit. So enumerate is a really helpful method. So here you can see 0. At 0 index we have apple, at 1 index we have cherry, at 2 index we have banana, at 3 index we have pineapple, at 4th index we have watermelon. Okay, so enumerate is also really important. So these are the two way how we can loop through the list. Okay, and now let's move to fourth one, which will be list comprehension. This is also a really important topic. Okay, so what list comprehension is? List comprehension is a shorter way or more Pythonic way to create a list using a single line of code. Okay, and how the syntax looks like? If you just follow the syntax, it's cool. It's very simple. Okay, so how this syntax looks like? So expression for item in iterable, and then we add some condition. Okay, simple. So let's see. what this means. Expression means what you want in the list. Then item is basically the variable for each element in the iterable. Like here we saw that x was a variable, in fruit was a variable, index was a variable. Okay, I think you have already seen in when you were studying about for loops. Then we have iterables. So iterables means any sequence like a list, tuple, range, anything. Okay. Then condition is basically optional. It is an optional parameter which filter for what gets included. Okay. So let's suppose we are trying to find square of numbers. Okay. So how we can find the square of numbers? So just we can do square, and we can have what expression we want. We want to have the square. So this is the expression. Now we have to uh, have some items. So for x in, then we have to we want some iterables. Let's suppose we want or we are trying to create a list with a square of numbers in the range of 10, means from starting from 0 to 10. So this is our iterable. So range, because I told you what is iterable, any sequence like a list, tuple, or range. Then this is the item for x, and this is the expression what we want to do with this x. Every time we are getting a x from range 0 to 10. Initially we got 0, then we got 1, then we got 2, then we got 3 till 10. What we want to do with it, we want to do the square of it. Simple. So this is what list comprehension looks like. If I just go and write square, so I should get a list with a square of numbers from 0 to 10, because range is 10 and upper limit is excluded. Every time I told you in Python, every time upper limit is excluded. So we got till 9. Okay, cool. Similarly, okay, if you are not understanding it, let's suppose we have to find the square of numbers, and we have to create a list, and um, we have to find the square of numbers. So what we can do? Okay, so what was the traditional way? Okay, I'm writing. We are creating a new list, and then we will iterate over the list. Okay, so for I can say for x in range 10, and we will do the square and we will append it. Okay, so square t dot append, and then we will append the square of the x. So this is what we do in the traditional way. If I print the square t, okay, if I print the square t, this should give the same result as we have already obtained in 13 and 14 line. So this is also giving the same result, 0, 1, 4, 9, 6. Maybe you are more familiar with this approach. This is a traditional way, but this is more easier, or you can say more, this is a way to do the same thing. Okay, but this is how we can do with list comprehension. Both are same. Okay, I have just shown you to have a apple to apple comparison so that you can understand it in a much better way. Okay, then let's move and let's write another code. Let's suppose we want to filter only even numbers between range 0 to 10. Okay, we have 0 to 10 and we just want to create a list with even numbers. Okay, you can also do with the traditional way with using for loop, but I'm just using a normal list comprehension. So every time what we have to do, we have to have an expression. So in this part we just want the value. We don't want to do square, cube, nothing. So we will just write x. Okay, you can name anything, it's just a variable. Now for x, that is the item for x in iterable. What is iterable? Range. So range is 10. Now there was a, in syntax you can see there is a optional condition which was if. So if x modulus 2 is equals to 0, it means that we have to create a list from range 0 to 10 only and only when it is even. How we can check a number is even or not? We will just do modulus. 4 modulus 2. If the modulus gives us the remainder. If the remainder is 0, it means it is a even number. 3 modulus 2 is not equals to 0, so it is not an even number. So first of all, x means we have the expression. We don't want to find any square or something like that. So we will just write x. We just want that element as it is. Then for x, for item in range, we have an iterable, and then we added a if condition, which is a optional part. Initially we were not adding if condition because we don't wanted any you can say conditional part. If we wanted to just calculate the square of even number, then definitely this part we have to add it here also. Okay, so now if I just print the evens, okay, so let's see what I'm getting. So now I'm getting 0 to 468. So in the range of 0 to 10, okay, definitely 10 is excluded. So how many even numbers we have? 0 to 468, and we just got it by a simple list comprehension. Okay, so list comprehension, this is just an interview tip for you, that list comprehension are faster than traditional loops because they are optimized at the C level inside the Python. Okay, that's it for list comprehension. And we can also have a 2D list like this, matrix. In whenever you will sort DSA and all, you might come across it. We can have a list like this, list inside list. Okay, so we can have 3 comma 4. Okay, so if I just print this matrix, sorry, matrix, so this is list inside a list. Okay, so let me just print it. We got 1 2 3 4. Okay, how actually how it looks like? Okay, it's just a matrix. Okay, so whenever we write a list like this, let's suppose we have a variable as matrix, and we mentioned as, we created it like this, 1 comma 2, and then another list which is 3 comma 4. Okay, so it is we are creating a matrix where you can say, sorry, we have a list. And how the indexing works, this is basically zeroth index, this is one index, and at one index we already have a list. Okay, so now inside this list we again have an indexing which is 0 and 1, here also 0 and 1. So if you have to access this element, what will be the index? First index is 0, so it will be 0. Second index, which is list inside list, so first we got 0 and then we have to write another 0. So if you want to get the first element, it will be matrix 0 comma 0. It's just the simple matrix which we write like this, 1 2 3 4 in maths. Okay, this is the same matrix representation. Okay, so if you want to access the first element, how we can access it? Print matrix 0 comma 0. Okay, so first we move to the first list, because the first list indexing will be 0, and inside that list again we are trying to access the first element, so that's why we added 0 0. So if you just go here, we got 2, sorry, 1. Okay, and let's suppose we have to access this element 4. So how we can access it? First we will move to this index which is 1, and then, sorry, 1, it's not actually the syntax is like this. Okay, so first we got to 1, and then inside that 1, because at 1 we already have a list, and we want this last value which index, whose index is 1, so it will be again 1. Okay, so if I just do like this, uh, sorry, print matrix 1 1 and 1. Okay, so now I should get the last element which is 4, so we got 4, see, at the end. Okay, so this is how a 2D list also occurs. It means that you can also have a 2D list which is list inside list. Okay, now I wanted to give some interview tips, and I think I also need some space here, so we can add 05 interview tips.py. Okay, let me also clear it. First one is, lists are always passed by reference, not by value. Okay, it's kind of a shallow copy by reference. Okay, what I want to say is, it is passed by reference means, let's suppose we have a list as 1 2 3 and 4, and we assigned that list into another variable which is a. Now this is having a shallow copy. Okay, what I mean by shallow copy and all, I will explain you. Now if I append 4, I I have a list as A, then I copied into B, and in B I have appended 4. So A should not be affected. Okay, if I print A, it should just containing 1 2 3 4, because sorry, not 1, let me just remove 4. So it should just contain 1 2 3, because I have appended on B, I have not appended on A. But see, A is also changed, so that's why we should never use like this thing, B is equals to A, because it is if it is like it is basically all the lists that are having same value are assigned to a same memory location. If you want to see it, if you want to see the location of any variable, you can do like this. Okay, so if I do like this, okay, so now let's do this. See, 43486 and 434867146. So B and A both are referring to the same location as we have seen in the string. Okay, because it's much better way because to manage the memory in a much easier way, because uh, A and B are containing same uh, you can say same elements in the list. So why we should give another memory location? We can also, it can refer to the same location. So that's why lists are passed by reference. So A is passed to B by reference, means A and B in both are just a variable, but they are referring to a common location. Okay, so that's why we should not we should not ever use B is equals to A. Okay, cool. Um, so what should we use? So instead of that, we should use copy. Okay, we should use always copy. Okay, now if I just run it, see, I'm getting two different locations. For A, there is a different location, and for B, we have a different location. And even if I print A and B, I will get different value. So print A and then print B. So I will get a different value now. So see, I created a list as A, I stored 1, 2, 3. I copied the list into B and I added some value in only B. So A should not be affected. See, A is not affected 1, 2, 3, and for B we are getting 1, 2, 3, 4. So this is one of the way how you can do it. So this was one of the way. You can also do something like this. B, you can use something as slicing A. So this one. This is also one of the way. It will also do the same thing. Okay. So if I just run it, see, it is also doing the same thing. Both are same. You can use deep copy. Sorry, you can use copy, or you can use um, this slicing method. Okay, cool. But sometimes this is also not enough. Okay, this is sometimes also not enough. Let me show you. Okay, these are basic things that I want to teach you because this is really important. Let's suppose we created a nested list and we have a list inside list, like we already saw, 1 2 then 3 comma 4, and now I created a copy. Okay, let's name a list as shallow. So now nested dot copy that we have already seen. Okay, now if I do shallow 0 comma sorry 0 0 and I tried to change it to 99. Okay, so what I am doing is I have a list, uh, I have a list as nested. Okay, which is having list of list 1 2 and I have 3 4. Okay, cool. I have something like this. Now I am trying to access this location because this is zeroth index, this is one index. Inside the list, this is zeroth index, this is one index, this is zeroth index, it is one index. Now if I am writing something like this, nested 0 and then 0. So first we move to this 0 and then the inside one 0. So we went this. So and I am trying to modify this as 99. So this should be changed to 99. This is what I'm trying to do. In shallow I'm trying to make it as 99. Okay, so now if I print nested, so what should be the answer? Because we have used copy in, okay, like initially we were using copy, here also we used copy, and I changed something in the previous list. Sorry, I changed something in this new list. I haven't touched this previous list, so the previous list should not be changed. But see, the previous list has also been changed. Okay, so this is what shallow copy is. Okay, in shallow copy we don't modify the whole thing, we don't have an original copy of it. Okay, so instead what we should do, so we should something import a library which is copy, and we should do instead of doing like this, we should do something like this: copy dot deep copy. and we should pass the list name. The list is nested. Okay, now let's see what will happen. Now I changed only the shallow list. Okay, I just changed the shallow list. So the nested should not be affected. See, nested is not affected. If I want to if you want to show this shallow list, it has been only affected. So let's print it. So nested list is as it is 1 2 3 4 because we have changed something only in the shallow list, and so that's why only shallow list has been changed. This is the concept of deep copy. See, deep copy operation and arbitrary Python object. Okay, you can learn more about deep copy, but this is the difference. In normal copy, whenever you have nested loop or something else, okay, because lists are being passed as a reference, not by a value. So that's why whatever assignment or dot copy you do is basically creating a shallow copy, not a deep copy. Okay, and if you want to have deep copy, this is how you can use deep copy. Okay, so the deep copy is really really important if you want to copy the whole structure, okay, of it. Okay, not just the skeleton. Okay, so that's it. In the next video or the next section, we are going to solve lots of questions related to list. In this section, we are going to start solving some of the questions that can basically come in your interview. This is going to be coding questions, and I will show you the questions. The best way is you can just give it a try and solve it by your own, because till now we have seen all of the things that are required to solve the questions. Now it comes only to your problem solving. So please invest some time in your problem solvings. If I show you a question, don't directly jump into the solution video. Just pause this video and uh, try to solve it on your own. And still, if you are not able to solve that question, definitely you can see the solution of this questions. So let me create a new, I can say, um, coding uh, practice kind of a list. Now the first question that we are going to solve is find the largest um, number in a list. Okay, so a list of numbers will be given. We have to print the I can say the greatest one, okay, or the largest one. So let's suppose we have a list, maybe 37294, and we have to find the largest one. Okay, so let me create a list here, or I can say numbers. Let's suppose we have 3, 7, 2, 9, and 4. So what will be the largest one? Which will be 9. So please pause this video and give it a shot. So first solution is very simple. You can use just maximum. Okay, so largest is equals to max, and we can pass the numbers, the list. Okay, and this will basically give us the largest number. If I give it a run, so here we are, it will give us the largest value, which is 9, which is quite easy. But definitely I know that interviewer will not allow this, and he will say that don't use this type of functions. Please use some for loops and all. So how we can solve it using for loops? Let's see. So in this case, we have a list. The list is something like this. We have, sorry, let me just turn on this. So we have a list which is 3, 7, 2, 9, and 4. Now, if we have to find the largest one, we can have a variable. Okay. So largest. Okay, largest number. Let's suppose initially we uh, thought that we assume that this one is the largest one. So we stored this largest one. How we can store it? Numbers 0. Okay, because how we can access this? This is basically numbers, the list name, and the 0. This is, let's suppose we assume that this is the largest one. Now we move to this element and we checked. Is it largest? Is it greater than the largest element that we already have? So currently we have 3 as the largest one, but now we got 7. So yes, 7 is greater. So we will replace it. Now we move to this point. Our current number is 2. Is it greater than the largest value that we have? So let me just hide it. Okay, is it largest or it is greater than the largest value that we have? No, 2 is not greater than 7. Now we come to 9. So 9 is our current value and the largest value that we have is till now is 7. Is it greater than 7? Yes, it is. So we will replace it. And that at the end we have 4. So is 4 greater than the largest value that we have? No, it is not. So finally we got the answer as 9. So this is a very simple code I can say. Okay, so let's code this one. Let's code this one. So we can have a largest number and initially we will assume that the zeroth element is the largest one. Then we will keep moving here for num in numbers. Okay, and if num is greater than the already largest value we have, if the current number is greater than the largest number, then we can replace it. Largest is equals to num. Okay, and we will do this and at the end we will left with the largest value. As simple as that. So we can do this like this. Okay, also you can also replace this like this. Largest is equals to max of num comma largest. There are different ways. I'm just showing you all the way. Okay, you can also do like this, but I think this one is the much better way because we are not allowed to use any different type of functions. Okay, so this was the first question, which is find the largest number in a list. Then the second question that we are going to see is reverse a list. Okay, reverse a list. I think by the name it is clear. I don't need to explain this a lot. We have to reverse a list. Let's suppose we have a list like this. So list is 37294. We have to reverse it. Reverse it means the list should be now like 49273. Okay, so please, I have already solved this question in the section where we were explaining, where I was explaining about slicing. So please give it a try and let me know in the comment section whether you were able to solve this question or not. So one way is very simple. What you can do is print numbers that we already saw in the um, slicing part. So this is what we can do. So it will also it will just reverse the string. Okay, sorry, reverse the list. But definitely this will be not allowed. So what we can do is we have to do it using for loop. So let's again move to our whiteboard so that I can explain you in a better way. Okay, so let me just erase some part or this. Okay, let me erase this whole thing. So we have a list. It can be anything, maybe 1, 2, 3, 4, and 5. Okay, we have to reverse it. So what we can do, we can create a list. We can create an empty list. Okay, and now once we are at this position, every time we will store the element at 0th index. So we will store it at 0th index. Okay, so let me make this list like this. So initially we have an empty list. Okay, sorry, we have an empty list. So we got 1. So at 0th index we will store 1. We store 1. Now we move to 2. Again we will store it in 0th index only. So what is the 0th index? The first element. So now this list will become 2 comma 1. Okay, now we went to 3. Again we will store this in 0th index only. So now the list will become 3, 2, 1. Okay, again we came to 4. Every time we have to store it at 0th index. So once I will store it at 0th index, it will become 4, 3, 2, 1. Now we are at last element. Again we have to store it at 0th index. So it will be 5, 4, 3, 2, comma 1. Okay, so now if you compare this 1, 2, 3, 4, 5, we got a reverse of list, which is 5, 4, 3, 2, 1. As simple as that. Okay, so if we don't have to use slicing, we can do like this. Let's code it. Okay, so we have to create a empty list. So reverse list, I can name it as reverse list, and reverse list is like this. So it should be a list. I have to iterate over this for number in numbers, and I have to store every time I have to store it at 0th index. So here each and every method that we have learned, like insert, pop, these things will be useful. So how we can store it? We have to use insert, because wherever we have to insert some values at some index, we do like this. So I have to insert at 0th index, and I have to what I have to insert? I have to insert the num. Okay. So in the first iteration, we got at 0. Sorry, in the first iteration we got 3. So 3 will be inserted at this reverse list, and this list will become like this. Okay, then in the next iteration we will get 7. 7 will be stored at 0th index. So what is 0th index of the list? First value. So it will be 7 comma 3. Then and so on it will be becoming. Then we got 2. So it will be 2 comma 7 comma 3, and so on. Okay, that's all. So if you print this reverse list, I think you should also invest some time. Don't just look at the video, and maybe you will not be able to understand anything. But please try to also do it on your own. Try to do dry run and try to code along me. Think of the solutions. Once you invest your brain, then if you come to solution, it will be much more better, much fruitful, and much better for you also. So this is how we can reverse a list. Okay. So now the next question is we have to do remove duplicate from a list. Okay. So the next question that we are going to see is remove duplicates from list. Okay. A list of elements will be given. Let's suppose we have a nums list, and it is having 1 comma 2 comma 2 comma 3, sorry, 3 comma 4 comma 4 comma 5, and we have to remove the duplicates. Okay, so how we can do it? So it's a very simple. Let me again go to this board and I can explain you. Okay, we can just take a list here. So the list name can be anything. It's nums here: 1 comma 2 comma 2 comma 3 comma 4 comma 4 comma 5. Okay, so now we will have a list which will be our lookup list. Okay, so we will have a I can add it here. Okay, we can have a lookup list. Maybe the list I can add it here. Okay, this will be our lookup list. Initially it will be empty. Now we will see. Okay, we are at 1. So we will see this is our lookup list. Okay, so I will say, I will go and ask, this is basically nums. This list name is nums, and this will be our lookup list. Okay, so I will say, hey lookup list, do you have 1? No. So lookup list will say, no, I don't have 1. So 1 is basically, you can say, um, this is unique, I can say. Okay, so um, I can have I can append in this lookup list or unique list as 1. Okay, now I went to 2. A lookup list or unique list, or in this case we are calling it as lookup list. This is also going to our final list. Do you have 2? No, I don't have 2. So I will add 2. Okay, then we went to 2. Hey list or lookup list, do you have 2? Yeah, I already have 2. Means 2 is duplicate. We don't have to add it. Go away. 3. Hey lookup list or unique list, do you have 3? No, I don't have 3. So add it, because this is unique. It's not duplicate. I went to 4. Hey lookup list or unique list, do you have 4? No, I don't have 4. So this is also unique. Then comes here. Hey lookup list, do you have 4? Yeah, I already have a 4. So definitely this is not a unique number. So we will move forward. 5. Hey lookup list, do you have 5? Yes. No, I don't have 5. Sorry. So this will be also unique. So now we got a final answer which is containing. We have removed all the duplicates, and it is only containing unique values. Okay, that's all. So let's code it. It is also very simple. So we will have a lookup list, or let's call it as unique list. Okay, this will be our final list. So for num in nums. Okay, if num not in, okay, if it is not in unique list, then only we will append it. Okay, so unique dot append, we have to append, what do we have to append? We have to append num. Okay, simple. Print unique, as simple as that. Okay, let me just clear it, give it a run. So we got 1 2 3 4 5. So 2 was duplicate and 4 was duplicate. We removed the duplicate elements. Okay, simple, very easy. Okay, if you are having some confusion, please go through this video again. Please try to solve it on your own, because if you will not solve it on your own, you will never develop your problem solving skills. Okay, always think, whenever you got a problem, always think like, as a human, how I will be able to solve it. Then the same instruction I have to give to the system, nothing else. Okay. Then we have a flatten list topic. Okay, so flatten list. Flatten. This is a basic question, but lots of time it is asked. Flatten list means we have a nested list, 2D matrix that I have told you. So we have 1 comma 2, and we have another list, 3 comma 4. So how the answer should look like? It should be printing a list, simple 1 2 3 4. So we have to flatten a 2D list. So how we can do it? It's simple. Okay, let me let's go to the whiteboard and or to my pad, and I can show you. So we have a list which is having 1 comma 2. Then we have 2 comma 3, not 2 comma 3, 3 comma 4. Okay, so what we have to do is, first of all we will iterate over this big list. So first we will get here, then we will get here. So in first loop we will get this part, then we have to again add a loop inside this. So what I want to say is we have to add two loops. Okay, first loop will iterate over this list. First will be this element, second will be this element. The second loop will iterate inside the list. Okay, whenever there will be first loop, we will get a list which is 1 comma 2 at first time, and then we have to iterate over this list. Okay, let me write the code. I think you will understand much better. So first, for sublist in nested. Okay, so this will give me the lists, like one, this list, then this list. It will give this list, but I have to also iterate over that sublist. So for item in sublist, now we got, this is our sublist, and when we iterate over this sublist we will get item. So what is item? 1, then 2, this is the item, and we have to add this item somewhere. So I can just create a variable, flatten, flat I can say. Okay, so flat dot append, I want to append the item, as simple as that. Okay, if I just print the flat, I get the answer, which will be 1 2 3 4. Okay, I think if you have understood, but if you have not understood, let me explain it again. So so what we want to do is, um, first of all we want this list and so on, and then we can iterate inside the list. So if I write like this, for sublist in nested. Okay, suppose this is nested. Okay, so this sublist, what will be the sublist? The element of the list. What are the elements of the list? List. This is one element, this is one element. So this sublist, at the first time, this sublist will give me 1 comma 2. Okay, now inside this sublist, for item in sublist. Okay, so for this sublist I have items. So I have a list 1 comma 2. So what I have list 1 comma 2 for this instance. For what will be the item will be one by one. Once I will get 1, then I will get 2. So that's why I am appending it. So whatever I have a flat list, so flat dot append the item. It means that once it will append 1, then it will append 2. Then the next time, this sublist will be having 3 comma 4. So this sublist will be having 3 comma 4. What will be the item for 3 comma 4? 3 and 4. It is also a list. So we will append 3 and 4 also, and finally we will get 1 2 3 4. Okay, I think this is also a easy question, which was flat and list, but this all questions are asked in an interview. Okay, so please focus on it. Okay, yeah, at least you should know this type of question. Now, can we flatten this list using list comprehension? Definitely, we can also flatten this list using list comprehension. So what we can do is, how the list comprehension will look like. Flat is equals to, first we have to take the item, because in list comprehension the first element is what? is the operation that we have to perform. We don't have to perform any operation. We just want the item as it is. Okay. But for sublist in nested, and for this sublist, again we have to get the items. So for item in sublist, simple. This is one liner that you can use if you can understand it. Okay, because sometimes this type of syntax and all becomes a bit tricky. This is also the same. So this is also print 1 2 3 4. So this is our expression. So we don't have to perform any operation or expression. So we will just choose item for sublist in nested, because this is our nested list, and for sublist for each list, because this is a sublist, this is a sublist. So for each sublist we have to again iterate. So for item in sublist, so and we are going to store that item. Simple. So this is also a way which you can use to flatten the list using list comprehension. If the interviewer asks that, can you perform list comprehension? Okay, if they want to check your list comprehension skills, as simple as it. Okay. So the last question that we in list that we are going to tackle is find second largest number. Okay, second largest number. So initially we have seen how we can find the largest number. Now we will see how we can find the second largest number. Okay, so please give it a try. It is a good question. It can develop your skills. Even if you are not able to solve it, it's fine, but please give it a try. Okay, so let's suppose we have numbers. Okay, we have a list of numbers: 10, 20, 4, 45 and 99. Okay, so let's suppose the way we solve the largest one, we are also going to solve the second largest one. Okay, let's focus. Okay, so it's 99. So what we are going to do, we are going to store two different variables. So first we'll be storing the first largest number, second we'll be storing the second largest number. Okay, and initially we are going to store just I can say we are going to store um, minus infinity. Okay, because any number will be always greater than minus infinity. Okay, cool. Now, okay, so see how easy this question is. We went to 0. Okay, so we will check if the number is greater than first. Yeah, this number is greater than first, because first is minus infinity and with the number that we are having is 10. Yeah, it is 0. So what we are going to do is, so what if we find a number which is greater than the greatest number, because first is the greatest number that we have. Second is the second smallest number. Okay, so we got a number which is greater than the greatest number that we have. Okay, so that's why in this case we will, now the highest number will become the second highest. So the highest number, which is minus infinity, now will become the second highest, and the number that we have will now become the first highest. Okay, currently both are minus infinity, so you will be not able to see the thing, but this is how it is. Okay, okay, cool. Now we have like this. Okay, so okay, cool. Now we have 20. Okay, now we moved to 20. Now I ask you that ask yourself that 20 is the number. Is it greater than the greatest number that we have? The greatest number is first. Yeah, it is greater than the greatest. So now the highest number will become the second highest. So we will make the highest number as second highest, and we will add the number as the highest one. Cool. Let it be. Now we come to 4. Is 4 greater than the highest number we have? No, it is not greater. But it can be a candidate to become a second highest. But how it can become a second highest? If the number is greater than second highest and smaller than first, then we can say it is a second highest number. So 4, is it greater than second? No, it is not greater than second, so it cannot be a candidate. So nothing will happen. Now we came to 45. Now tell me, 45, um, or what I can do is to explain you better. I should make this number as 15. Okay, that will be a better opportunity for us. Okay, so now see, we have a number. Okay, so 15. Is 15 greater than the greatest number we have? No, greatest number we have is 20. It's not greater. Okay, so it is not greater than, it can be a candidate for second greatest. Yeah, it can be. So is it more than second highest? Yes, it is more than second highest. Is it less than the first highest? Yeah, it is less than, also it is less than the first highest. So I can say it can be a good candidate for second highest. So I can add 15 here, and the first highest will be as it is. We don't have to uh, change, okay, anything. Cool. Now we come to the last element, which is 99. Now, is 99, or the number that we have, is it greater than the greatest element? Yeah. So now the first highest, whatever number we were having till now, the first highest, we will make it at as second highest, and the number, the current number will become the first highest. So now we have the first highest as 99 and second highest as 20. So this is how the uh, how everything will look like. Okay, so let's see the code of it. Okay, so what we can do is we can have a nums, and we can have 10, 20, 30, no sorry, we can have 10, 24, 15, and then 99 that we took. Okay, so we will create two variables, first and second. You can also create like this. Okay, and we have to store minus infinity. This is really important, how you store minus infinity in Python. It's like this, minus inf. Okay, so this is a way to store minus infinity. We created two variables, first and second. We stored minus infinity. Now we have to iterate over this list for num in nums. Okay, what was the first condition? If the number is greater than the greatest number we have, what is the greatest number we have is first. So in this case, the greatest number that we have till now will become the second greatest. So we stored first in the second, and now the number that currently we have will become the first highest. Okay, so now another condition is in elif, that if the number is not greater than first, then it may be greater than second. Okay, and so we have to check if whether it is greater than second or not, and smaller than first or not, and then we will store the second is equals to none. Okay, as simple as that. So if we print both first and second, so it will be printing 99 and 15, so 99 and 20. So this is the way you can find the second highest. Mostly in interviews, when you solve the question for first largest number, they generally ask about second largest number also. So you should know this thing. Okay, this is a very basic thing. You just have to, uh, if you were not able to solve it, just look at this video and try to understand the logic, and so that if you face this question in interview, you should not fail. Okay, so that's it. In the next section, we are going to see about tuples. In this section, we are going to see about tuples. So first of all, we will see what actually tuples are, and then we will see some operations on tuple. So let me create a new file, which will be 07 tuple.py. Okay, so also let me clear this terminal for this moment. So what actually a tuple is? Tuple is similarly to list, but it is ordered and immutable collection of items. Okay, so the main thing is list is mutable, but tuple is immutable. Let's see how we can define a tuple. Okay, so we can name it anything. Let's suppose my tuple, and in this in list we were using square brackets, but here we will be using this normal brackets. So this is now a tuple. Okay, we can also so if I print this tuple, my tuple. Okay, so and also let me also print the type of my tuple. Okay, how which type this my tuple is. Okay, so if I just print it, so if I got a tuple which is 1 2 3, in list it was in square brackets, but it in tuple it is in normal brackets, and it is a tuple object. This is one way of defining tuple. You can also define something like this: 1 2 3. Okay, without any brackets. This is also a tuple. Okay. If you have to define a tuple with just one element, so is this correct? No. Okay, it is thinking that this is an integer. So if you are passing just one value and you want to make it as tuple, so you should add a comma here. Now it became a tuple. Okay. So this is an important part. You should always include comma, but generally we declare tuple like this. Okay, so it is 1 2 3. If we just have one value, then we should add a comma. Okay, now let's see how we can access the element of um, accessing elements in tuple. Okay, it's similar to list. Okay, in list we were also using the indexing where the indexing starts with 0. Similarly in tuple also the indexing will starts with 0. So there is no difference. If you have already understood the accessing part of a list, then the same will go here also. So if I do print my tuple, whatever it has 0, okay, so it will give me the first element which is 0, which is 1. Okay, so in 1 2 3 at 0th index we have 1, at -1 index we have the last element which is 3, so it will give 3. The accessing part is very similar to what we have already seen in list. Okay, then there is an important concept which is called as tuple packing and unpacking. So let me show you how this looks like. Tuple packing and unpacking. Okay, so let's suppose we have a variable a and we have a variable 2. Now we want to create a tuple out of it. So how we can create? We will just add braces and a and b. This is basically we call it as packing. Okay, this is called as packing. How we can unpack it? We can also do like this: x and y is equals to t. So now t was containing two elements, 1 and 2. Okay, but we have also unpacked it, and now x and y will be containing the value of the tuple which was 1 and 2. So if I print x comma y, so I should get 1 and 2. So initially we had two variable 1 and 2. We created tuple out of it with a and b, which was packaging, and then we unpacked it. So t, which was a tuple, now unpacked into x and y variable, which became that, so that we printed x and y. So this is how packing and unpacking works. Okay. Um, it is basically helpful. Like let's suppose you have a method. Okay, you can have any method, and it let's suppose it is returning something. Okay, it is returning tuple. Let's suppose sorry, it is returning a tuple. Let's suppose some marks 10 and 20. Okay, now when I call this method, it is returning a tuple, so I can also unpack it. Let's suppose marks 1 and marks 2 is equals to stats. So whenever I will call this stats method, it will return a tuple which will be 10 and 2. But I am also unpacking it into two different variables, marks 1 and marks 2. So if I print marks 1 and marks 2, so I should get um, 10 and 20. Okay, so let me just comment it out. So I should get 10 and 20. As simple as that. So this packing and unpacking are lots of time very helpful. So that's why I am showing it to you. Then similarly, as we have seen in list, in tuple also, these methods are really helpful. Some basic methods like 10 20. Let me add some values here. So we have a tuple like tuple here, and if we have to find the length of the tuple, we can pass it length of the tuple. So what will be the length of the tuple? 10 20 30 40. So the length will be 4. Similarly, we can print the what we can do, count. Similarly, that the same, this is the same method that we were using in list. So do we have, what is the count of 20? So the count of 20 is only 1. Okay, we are getting just once. Then we can also do the same as t dot index. Okay, it will give us the index of the element. So what is the index of 20? It's 1, because 20 is at present at 1 index, because indexing starts from 0. Okay, so this all are the similar methods that we have already seen in the list, so that's why I'm going a bit fast forward. Then we can also do slicing. If we just use the same tuple 10 to the 40, and let's suppose we just want the first two elements. So what we were doing in the list, the same thing we are going to also do in tuple. So tuple and square brackets, and we want first two elements, so 0 and 1 we want. So we will write 0, and we also want 1, so we will increase it, because if we just write 1, 1 will be excluded. So now it will give 0 and 1, 2 will be excluded. So 10 and 20 will be printed. So 10 and 20 is there. If it is 0, so you can also leave it as it is. So it will also give 10 and 20. Simple. Okay. If you want to reverse a tuple, simple. What you can do? -1, as we have seen in the list. So I'm not going to explain a lot. So it will be 40, 30, 20, 10. Okay. So we have also reversed it. Tuples are basically immutable. Okay, so we have a tuple here, and if we are trying to change some values, like in list we were able to do this. Let's suppose at 0th index, instead of 10 I want 100. So it was basically performing in case of, it was this method was this operations we were able to perform in case of list, because lists were mutable, but tuples are not mutable. So if I just print this t, it should give me some error, because see, tuple object has no support item assignment, so we cannot assign something in tuple, because tuple is immutable. Okay, so this is but one more thing. If someone asks you, this is, please listen carefully. We have a tuple like this. Okay, so we have a tuple like this, 10, 20. Inside tuple, we can also add list 10, 20. Oh, maybe 10, not 10, 20, 30, 40. Okay, okay. Now, I cannot. This is not good. I cannot perform this. Okay, if I do like this, definitely if I print this t, it's not going to work. Okay, because tuple object does not support item assignment. But inside this tuple, I have a list, and at which index I have a list? I have a list at 0, 1, 2 index. Okay, so at 2 index, I have a list, and in this list, I want to modify the first element, so which is at 0th index. So at 0th index, so at first I made like I wrote like this, t square bracket 2 means at second index. So in second index I have a whole list. Out of that I want 0th index. So can I modify this? Yes, because list is mutable. Okay, we are not changing a tuple, we are changing actually the list. So this is good, we can perform it. So if we have a list inside a tuple, we can mutate it, but if we just try to mutate plain tuple, we can't do it. Okay, now, when to use this tuple? So whenever we are returning multiple values from a function or protecting data from modification, we can use this tuple as a keys, because these are immutable. Or if we want faster access, we can use tuples. Okay, so that's it. I guess this much is enough, because basically in industry we use list by default. We just use tuples only when we need to make sure that data should not change. Okay, and lists are more commonly used in development due to their flexibility, and tuples are used when data remain we want the data should remain constant, or when performance, like performance is a concern, where due to immutability we don't want to compromise with performance, then we use tuple. So if we compare apple to apple for this list and tuple, mutability, list is mutable, tuple is immutable. In terms of speed, list is slow, tuple is faster. Hashable, list is not hashable, tuple is hashable, because all the things that those are immutable are hashable. Okay, syntax wise, it's simple. We just use square brackets. So here you can see this square brackets are for list, and the normal brackets are for tuple. And can we use it in a dictionary as a key? Yes, list cannot be used, but tuple can be used, because all the things that are mutable cannot be used as a key, because they are not hashable. Okay, so in tuple, it can be used in a dictionary as a key, but in list it cannot, because list is immutable. Okay, so that's it. I think we have seen lots of things in list and tuple. Mostly list is really really important. Whatever you have learned from list, you can also apply most of the things in tuple, and generally questions are from list only, but we should also know tuple. Tuples are also like packing, unpacking are heavily used. So this is really really important. Okay, so we have covered lots of things in this thing in this masterclass, like the basics, common list methods, looping, list comprehension, shallow and deep copy, very important thing. Then some coding questions, interview level tips, tuple introduction, tuple and packing, unpacking, slashing, immutability, and the use of tuples. So that's it, and I will post this whole masterclass code here, whatever we have seen in the VS Code, and you can find it in the description box so that you can clone it and play with it. And so if you find this video meaningful or helpful for you, please feel free to subscribe. And if you have any doubts, anything, any complaints, please let me know in the comment section so that I can improve myself and I can go through your comments. And if you have any doubts also, please let me in the comment section. I can help you. That's it. Meet you in some other masterclass. Till then, bye bye. Thank you.